Hariom students, all of you are obeying the instructions given by our government for our safety. You maintain 2-meter distance away in public place. Always you remember it. Then what is the meaning of Swamiji saying make a success out of the failures of today? ഇന്നത്തെ പരാജയം നാളത്തെ വിജയമാക്കാൻ നമ്മൾ ശ്രമിക്കണം. ഏതെങ്കിലും ഒരു കാര്യം ചെയ്ത് പരാജയപ്പെട്ടെന്ന് നമ്മൾ പിന്മാറാൻ പാടില്ല. നമ്മളത് നന്നായിട്ട് ഒന്നുകൂടെ കഠിനമായി പരിശ്രമിച്ച് നല്ല രീതിയിൽ ചെയ്തിട്ട് വിജയം നേടാൻ ശ്രമിക്കണം. അതുകൊണ്ട് ഏതൊരു കാര്യം ചെയ്യുമ്പോഴും ആദ്യം ഒരു പരാജയം വന്നു എന്ന് വെച്ചാൽ നമ്മൾ പിന്നെ ചെയ്യാതിരിക്കുകയാണ് ചെയ്യേണ്ടത്. ഇപ്പോൾ എക്സാം പീരിയോഡ് ടെസ്റ്റ്, ഫസ്റ്റ് പീരിയോഡ് ടെസ്റ്റ് നിങ്ങൾ എഴുതി അതിൽ ഇച്ചിരി മാർക്ക് കുറഞ്ഞു സെക്കൻഡ് പീരിയോഡ് ടെസ്റ്റ് എഴുതണ്ടെന്ന് വയ്ക്കുകയാണ് ചെയ്യുന്നത്. അല്ല, നമ്മൾ സെക്കൻഡ് പീരിയോഡ് ടെസ്റ്റ് ആകുമ്പോൾ ഒന്നുകൂടെ നന്നായിട്ട് പ്രാക്ടീസ് ചെയ്ത് പ്രോബ്ലംസ് ഒക്കെ ചെയ്ത് പഠിച്ച് നമുക്ക് എന്താണോ കഴിഞ്ഞ പരീക്ഷയ്ക്ക് പരാജയം സംഭവിച്ച് അതിൽ നിന്നൊക്കെ നമ്മൾ ആ തെറ്റുകൾ മനസ്സിലാക്കി നമ്മൾ കറക്റ്റ് ചെയ്ത് മുന്നോട്ട് പോകണം. അപ്പം നമുക്ക് നല്ല ഉയർന്ന ഒരു വിജയം ഉണ്ടാകും. അങ്ങനെയാണ് നമ്മൾ ശ്രമിക്കേണ്ടത്. ഓക്കെ, സോ മേക്ക് എ സക്സസ് ഔട്ട് ഓഫ് ദ ഫെയിലിയേഴ്സ് ഓഫ് ടുഡേ. ഓക്കെ, ദെൻ we study the similarity criterion for triangles SAS, ASA criterion for similarity. What is SAS similarity criterion? Bedari. If in two triangles, if two sides and the two sides are proportional to the two sides of the other triangle and the angle included between these sides are equal, then we can say that two triangles are similar. That is SAS similarity criterion. Today we can study the properties of areas of similar triangles. There are some properties for areas of similar triangles. Then the ratio of the areas of similar triangles is equal to the square of the ratio of the corresponding sides. So if the ratio of the areas of similar triangles is equal to the square of the ratio of their corresponding sides. So if the two triangles are similar, then the ratio of their areas is equal to the square of the ratio of their corresponding sides. You can take an example. This is triangle ABC. Triangle ABC, and this is triangle PQR. Then it is given that triangle ABC is similar to triangle PQR. Triangle ABC is similar to triangle. Then by this theorem, the ratio of the areas, what is the ratio of the areas of these two similar triangles? It is equal to the square of the ratio of the corresponding sides. Then what is the ratio of the areas? Is equal to area of triangle ABC by, here we can read as area of triangle ABC by area of triangle, second triangle is triangle PQR. Area of triangle ABC by area of triangle PQR, it is equal to the square of the ratio of the corresponding sides. Then what is the corresponding side to AB? PQ. Then what is the square? AB by PQ is equal to AB by PQ the whole square, or it is equal to, what is the another corresponding side, or it is equal to the corresponding side to BC is QR, or it is equal to BC by QR the whole square, or it is, what is the third corresponding side to AC? AC is the corresponding side to AC is PR, or AC by PR the whole square. That is, the ratio of the areas of similar triangles is equal to the square of the ratio of their corresponding sides. Here it is given that triangle ABC is similar to triangle PQR. Then what we can say about their areas? Then the ratio of the area of triangle ABC by area of triangle PQR is equal to the ratio of the square of the ratio of their corresponding sides. Here the corresponding side to AB is PQ. Then area of triangle ABC by area of triangle PQR is equal to AB by PQ the whole square, or it is equal to, what is the another corresponding side? BC. BC by QR the whole square. Or it is also equal to the third corresponding side square ratio. That is AC by PR the whole square. This is the property for areas of similar triangles. So the ratio of the areas of similar triangles is equal to the square of the ratio of the corresponding sides. In this here it is given that if triangle ABC is similar to triangle PQR, what can we say about their areas? That the ratio of the areas is area of triangle ABC by area of triangle PQR is equal to the corresponding side square. That is AB by PQ the whole square, or it is equal to BC by QR the whole square, or AC by PR the whole square. So you remember the property. The ratio of the areas of similar triangles is equal to the square of the ratio of their corresponding sides. Okay. We can do one problem. Triangle ABC is similar to triangle DEF and their areas be respectively 64 cm square and 121 cm square. If EF is equal to 15.4 cm, find BC. It is given that triangle ABC, this is triangle ABC, is similar to triangle DEF, triangle DEF, and it is given that DEF, and the areas of these two triangles are given. The triangle ABC is 64 cm square and triangle DEF is 121 cm square. And what is the length of EF? EF is equal to 15.4 cm. EF is equal to 15.4 cm. Then you are asked to find BC. Then here we can use the theorem. The areas of similar triangles is equal to square of the areas of their corresponding sides. So what we can say here, we are asked to find BC. So we can take the corresponding sides to BC. Okay. Then area of triangle ABC by area of triangle DEF, is equal. We can take the corresponding side to BC, EF. Then it is equal to what is the square of the areas of their corresponding side. So it is equal to BC by EF the whole square. BC by EF the whole square. Or it is equal to AC by DF the whole square. Here we are asked to find BC. So we take the corresponding side to BC. Then the corresponding side to BC is EF. So area of triangle ABC by area of triangle DF is equal to BC by EF the whole square. Okay, RSB, what is the area of triangle ABC? It is given in your question. The area of triangle ABC and area of triangle DF are respectively 64 cm square and 121 cm square. Then what is the area of triangle ABC? 64. That is 64 by the other DF is 121 is equal to BC. We are asked to find BC. BC by 15.4 the whole square. 15.4 the whole square. Or we can write it as 64 by 121 is equal to BC square by 15.4 into 15.4. Then what is BC? Therefore BC square is equal to 64 into BC square is equal to 64 into 15.4 into 15.4 the whole by 121. Then what is the square root of BC? Therefore BC is equal to square root of 64 into 15.4 into 15.4 the whole by 121. Then what is square root of 64? Square root of 64 is 8. Then as you know, what is the square root of 15.4 into 15.4? If the numbers are in pairs, the square root is we take 1 from this pair. Then it is equal to 15.4 the whole by what is square root of 121? It is equal to 11. then it is equal to 8 into 15.4 by 11. What is 15.4 into 8? 15.4 into 8. That is 123.2 by 11. 123.2 by 11. It is equal, we can do it here. 123.2 divided by 11. How many times? 1, 11, then 13, 1 time. Then we put a point and then 22. How many times? 2 times 22. Remainder 0. So, what is 123.2? That is equal to 11.2. That is equal to 11.2 centimeter. Therefore, what is the length of BC? Therefore, BC is equal to 11.2 centimeter. So, here the areas of the similar triangles are given and one side is also given. You are asked to find the other side. We use the theorem. Areas of similar ratio of the areas of similar triangles is equal to square of the ratio of the areas of their corresponding sides. Therefore, area of triangle ABC by area of triangle DEF is equal to BC by EF the whole square. Then 64 by 121 is equal to BC by 15.4 the whole square. Here, so it is equal to 64 by 121 is equal to BC square by 15.4 into 15.4. Then what is BC square? Cross multiplying what we get? It is equal to 64 into 15.4 into 15.4 by 121. Then BC is equal to square root of 64 into 15.4 into 15.4 by 121. Then we know that the square root of 64 is 8. Then 15.4 into 15.4, the square root is, we take 1 from this each pair. Therefore, it is equal to 15.4 and the square root of 121 is 11. Then it is equal to 8 into 15.4 by 11. That is equal to 123.2 by 11. That is equal to 11.2 centimeter. Therefore, what is the length of BC? Therefore, BC is equal to 11.2 centimeter. Okay. Next, a theorem. If a perpendicular is drawn from the vertex of the right angle of a right triangle to the hypotenuse, then the triangles on both sides of the perpendicular are similar to the whole triangle and to each other. Here, if we draw a perpendicular from the right angle of a right triangle, let triangle ABC is right angled at B. Right angled at B. Then we draw a perpendicular from this right angle to the opposite vertex. To the opposite vertex is, what is the side opposite to the right angle? Vaishnav, what is its name? The side opposite to the right angle is hypotenuse. So, if we draw a perpendicular from the right angle to its hypotenuse, then it divides this figure into two triangles. Then it divides this big triangle into two small triangles. Then the two triangles are similar to the whole triangle. Whole triangle means this triangle ABC, and they are similar to each other also. If we draw a perpendicular from the right angle at B, we draw a perpendicular to the hypotenuse. The hypotenuse is AC. Then if we draw a perpendicular B to D, then this triangle ADB is similar to the whole triangle, that is triangle ABC, and this triangle BDC is also similar to this whole triangle, that is triangle ABC, and these two triangles are also similar to each other, that is triangle ADB is similar to triangle BDC also. Here, by this theorem, triangle ABC is right angled at B. Then we draw a perpendicular from B to the hypotenuse. Then triangle ABC is similar to this triangle, triangle ADB, and triangle ABC is also similar to triangle ABC is similar to the other triangle, that is triangle BDC. Triangle BDC, triangle BDC, and these two triangles are similar to each other also, that is triangle ADB and triangle BDC are also similar, and triangle ADB is similar to triangle BDC. So by this theorem, if we draw a perpendicular from the right angle of a right triangle to its hypotenuse, then we get two triangles. That two triangles are similar to the whole triangle and they are similar to each other also. That is the theorem. That is here a triangle ABC is right angle at B, then triangle ABC is similar to triangle ADB, and triangle ABC is also similar to this second triangle, triangle BDC, and these two triangles are also similar to each other. That is triangle ADB is similar to triangle BDC. Okay. That is, if a perpendicular is drawn, the vertex of the right triangle, this is the vertex of the right triangle of a right triangle to the hypotenuse. AC is the hypotenuse. Then the triangle on both sides of the perpendicular, that is the triangles on both sides of the perpendicular are similar to the whole triangle. That is, these two triangles are similar to this whole triangle, means triangle ABC, and the similar to the whole triangle and to each other also, are similar to the whole triangle and to each other. That is means they are similar to each other. That is triangle ADB is similar to triangle BDC. In this figure, triangle ABC is similar to triangle ADB. Triangle ABC is also similar to this triangle BDC, and these two triangles are also similar to each other. That is triangle ADB is similar to triangle BDC. Okay. So if a perpendicular is drawn from the vertex of the right angle of a right triangle to the hypotenuse, then the triangles on both sides of the perpendicular are similar to the whole triangle. These two triangles are similar to this whole triangle ABC and to each other also. Okay. Similar to the whole triangle and to each other. Okay. So you remember the theorem. It is useful while doing problems also. So if we get a right angle triangle, and if the from the right angle of a right angle triangle, if we draw a perpendicular, then what is the property of these two triangles? These two triangles are similar to the whole triangle and they are similar to each other also. Remember it. That is, if we draw a perpendicular from the right angle of a right triangle to its hypotenuse, here AC is the hypotenuse, then triangle, this big triangle is, the whole triangle means this triangle. Triangle ABC is similar to the triangle ADB, and triangle ABC is also similar to triangle BDC, and these two triangles are also similar to each other. That is triangle ADB is similar to triangle BDC. Remember it. These two triangles are similar to the whole triangle and they are similar to each other also. You remember it. Okay. We can do more questions in the next class. Assignments will be given through Google Classroom. Thank you and hari you.